Good evening, class. Welcome to Math with Mrs. Albright, and tonight we are working on Module 1, Lesson 13, and our objective is to use place value to subtract multi-digit numbers. So yesterday we practiced addition. Today we are doing the opposite with practicing subtraction. So make sure you have your scratch paper or a whiteboard handy, and let's get started. Our first problem is 4,259 minus 2,171. I want to visualize what this looks like as a tape diagram. We know that addition is part plus part equals whole. Well, subtraction is the opposite. Here we start with the whole, which we know is 4,259, and we know one of these parts, 2,171. If we take that part away from the whole, we will find out what this part is. So this is the part of this tape diagram that we're trying to figure out. To start solving this, I'm going to draw a place value chart and label it ones, tens, hundreds, and thousands. And I'm going to model this number, my whole number, in the place value chart using number discs. So I'm going to start with 4 thousands, 2 hundreds, 5 tens, and 9 ones. Now I can start subtracting. The number that I'm subtracting from this whole number is 2,171. And I'm going to start subtracting with my smallest place value. You always want to start with the ones first. So here I have 1 1 that I need to take away. When I look at my tens, I have to take away 7 tens, but I don't have 7 tens in this column available. So what I need to do is regroup. I need to take one of these hundreds away and turn it in to 10 tens. Now I have enough tens in this column so that I can take 7 away. And you can see that I'm left with 8. Now I'm going to move to my hundreds column. I need to take away 100. And I still have 100 there, so I can go ahead and take that away. And then finally, I need to take away 2 thousands. So to record my difference, I just count the number of dots that are left. I have 2 thousands, 0 hundreds, 8 tens, and 8 ones. So I have 2,088 as my other part. Now I can check my work and see if I did this correctly by adding these two parts together. If I add those two parts, it should equal this whole. Now we want to see what this looks like if we're just using this, what we call the standard algorithm, to solve the subtraction problem. 4,259 minus 2,171. And you'll see as I solve this with the numbers that this number disc models exactly what I'm doing with my digits over here. I'm going to start with the 9 minus 1. And remember, with subtraction, the order is very important. 9 minus 1 is very different than 1 minus 9. I always have to start with my whole number at the top. So 9 minus 1 is 8. So I can go ahead and record that in my ones column. Now I'm going to go to my tens column, 5 minus 7. But I can't take 7 away from 5. I don't have enough there. This is where I need to do that regrouping. So I'm going to turn those 2 hundreds into just 100. And I'm going to turn those 5 tens into 15 tens, just like I did over here in my picture where I did the regrouping. So 15 minus 7 is 8, 1 minus 1 is 0, and finally my thousands, 4 minus 2 is 2. And you can see how I got the same difference. Now it's your turn to try one. 6,314 minus 3,133. So remember, always start with the whole number. And when you start subtracting, start with the ones column and then move column by column as you get larger on the place value chart. Is 1. Now we have a larger number. 23,422 minus 11,510. Again, I can model this with the tape diagram, part, whole. I know that my whole is 23,000 10,422, and one of my parts is 11,510. So this right here is the part that I'm trying to figure out. Now I can do some estimating, and I can say that this whole is about 20,000, and this whole is about 10,000. So I know that this missing part is going to be about 10,000 as well, because 10,000 plus 10,000 would equal 20,000. So keep that number in your mind so we can check our answer. Now for this one, we are not going to use the place value chart. We're going to go right ahead and use that standard algorithm. 23,422 minus 11,510. When you rewrite the numbers, it's important to line up your place values. Make sure you're writing nice and neat so that your ones are lined up with your ones, your tens with your tens, your hundreds with your hundreds, thousands with thousands, 10,000s with 10,000s. And I'm going to start with my smallest place value. 2 minus 0, pretty easy. That leaves me 2. 2 minus 1 is 1. Now 4 minus 5, this is where I don't have enough hundreds to take 5 hundreds away. So I'm going to regroup one of these thousands. So instead of 3,000s, I'm going to make that 2,000s. And that 1,000 I took away is going to turn into 10 hundreds that I'm going to put together with the 14 I already have. So now I have 14 hundreds. 14 minus 5 leaves me with 9. Now I move to my thousand. 2 minus 1 is 1, and 2 minus 1 for my 10,000s is 1. So my final answer here is 11,912. Now, does that seem reasonable since my estimate was about 10,000? I think it seems pretty reasonable. Now, I can always use addition to check my work. I can take these two parts, the part that I knew at the beginning, 11,510, add it to this part, and see if I get this whole number. So let's check our work. I'm going to add the part I knew at the beginning, 11,510, add it to this new part, and when I add these up, I should get this as my answer. 0 plus 2 is 2, 1 plus 1 is 2, 9 plus 5 is 14, so I need to do some regrouping there. 1 plus 1 plus 1 is 3, and 1 plus 1 is 2. And now I can compare that to the original whole that I started with, and it matches, so I can feel very confident that I subtracted correctly and that this is right. Now it's your turn to try. 29,014 minus 7,503. Now when you rewrite this number, again, make sure you're very careful to line up the place values. Line up your ones with your ones, your tens with your tens, hundreds with hundreds, thousands with thousands. A really easy mistake would be to line up this thousands with this 10,000s, but you don't want to make that mistake. Start with your smallest place value. Now we're going to take a look at this within the context of a story problem. The paper mill produced 73,658 boxes of paper. 8,052 boxes have been sold. How many are left? Now, I know that this is a subtraction problem because they're talking about the difference between the total amount they started with and then what's left in the factory. So I can draw a tape diagram to model this problem, and my whole is going to be the amount they started with, how much they produced, which was 73,658. Now that's divided into two parts. One part they've sold, and I know what that part is, 8,052. And then the other part is the mystery that we're trying to figure out. How many are left? So I can do this using subtraction. I start with the whole number, 73,658, and I'm going to take away the part that I know, 8,052. 8 minus 2 is 6. 5 minus 5 is 0. 6 minus 0 is 6. 3 minus 8, now this is where I have to do some regrouping because 8 is larger than 3. So I'm going to take one of these 10,000s away, so now it becomes 6 10,000s, and I'm going to turn that one 10,000 into 10,000s and put them together with the 3 that I already have. So now I have 13,000s. So 13 minus 8 is 5, and 6 minus 0 is 6. So they have 65,606 boxes left. Now I can check my answer with addition because this is a part-whole problem. These two parts should equal this whole number. So let's check our work. I have 65,606 plus 8,052. 6 plus 2 is 8. 0 plus 5 is 5. 6 plus 0 is 0. 8 plus 5 is 13. 6 plus 1 is 7. And you can see I got the same answer that I started with, 73,658. So I can now write my sentence. There are 65,606 boxes of paper left. Now it is your turn to try with the story problem. The library has 50,819 books. 4,506 are checked out. How many books remain? So make sure you draw your tape diagram, practice sketching that out, and give me your final answer. What is the difference that you discover about how many books are left in the library? Please bring any questions you have back to class. We will continue working on this tomorrow, and I hope you have a great night.